In section 7.3, we're going to be simplifying radical expressions. We're going to be using a product rule to multiply. So in our first example, when we multiply this, we're going to get the square root of 110. Now we try to see if that is going to break down any further and see if anything square roots. And um, trying different factors of it for it to square root, it has to have a perfect square in it. Perfect squares are like 4, 9, 25, those type numbers. And 110 is not divisible by any of those, so we just stop right there. Next we have, to be able to multiply these, the indexes are going to be the same, have to be the same. So we have the cubed root of 5 times 10, which is 50. Now 50 doesn't have any factors that are cubed in it. It has a square, perfect square, because it's 25 times 2, but it doesn't have a cube, so there's nothing else we can do to this one. As well as the last example, so we can rewrite these as 6n and 5m, combine them together, but there's nothing else that simplifies in these either. So this is just getting you familiar with the format and multiplying radical expressions. Okay, this next part we're going to simplify, and there's many different ways to do this and different teaching styles for it, but we're going to take 27 and we're going to do prime factors. That's 3 times 9 is 27. When I get to a prime number, I'm going to stop and circle it, and 9 is 3 times 3. So my idea is that my target is my index. My index is a known 2, so I want to be able to write everything with an exponent of 2. It would be nice. So I can do 3 squared, because there's 1, 2 of them, and then I have 1 left over. So when our index, which is a known 2, matches one of the exponents, then it gets to come out. That number gets to come out. So I'm going to get to pull a 3 out front, and what's left underneath the radical bar is a 3, because that one doesn't have an index of it. So we're trying to target our index. And maybe you'll pick this idea up as we continue to go and understand where I'm going with this. So we look at 108, and we're going to do our prime factorization. That's 2 times 54. 2 is a prime number. 54 is 6 times 9. 6 is 2 times 3. Now we hit prime numbers. And 9 is 3 times 3. Okay, we have our prime factors. Now we want to look. Our target index is a 3. So I don't have that many 2's, but I do have 3 3's. So that's good. So I want to rewrite that as anything that I can write. I have 3 to the 3rd power, and that takes care of all of these. I don't have that with my 2's, so I'm just going to list them. Since I can't write it to the 3rd power, I can't target my index. I'm just going to leave them represented. So now that I have keep my index there, this exponent matches this index. That means this 3 in front is going to come out. So I'm going to get a 3. And underneath here, neither one of these have an index of a 3, so they're both stay under. So 2 times 2, I'm just going to leave the 4 underneath there. And I have to remember to keep my index. If my index is not a known 2, I have to represent it. Okay, so now we look at one with a variable. So I want to rewrite this as y to the 3rd. Okay, after I use up 3 of them, I have 2 of them left over. I chose to write this as y to the 3rd because I'm trying to target my index. I know that if I can make at least one of the exponents match my index, I can simplify it. Okay, so when that happens, because those two match, a y comes out front. This part right here comes in front of the radical sign. And since this exponent does not match my index, it stays under the radical. So I get y squared, and the original index was a cube, so I have to make sure and not forget this. Now that is y, and then this is my index. There you go. Okay, so now we're going to look at number 12. The next example. We're going to work with our coefficient first. We're going to work with 12, which is 4 times 3. 3 is prime, and 4 is 2 times 2. So now let's go back and look at our original index. There's nothing showing there, so our known index is a 2. So I want to know, can I rewrite anything? I do have 2 of something. I have 2 2's. So I want to rewrite my I have 2 squared, that takes care of these two, and I have a 3. Okay, now we're going to work with our variables, and there's a couple of ways to do this as well. I have to account for 9 r's, okay, but I also know that I would like to match my index, write it with an outside number of a 2. Well, I need to get as much of them as I can in there, so if I multiply it by 4, 4 times 2 is 8 right here. That gives me 8 r's. How many do we have though? We have 9. So that takes care of 8 of them and gives me an index of 2 for those. But I still also have that 1 left over. So I have to represent it. I can't lose it. Okay. Now we're going to move to the s's. I have 12 of them that have to be accounted for. But I know that if I can write it with an outside index of a 2, I can simplify this further. So what times 2 is going to give me 12? Well, 6, because a power to a power you multiply. So let's just check. I have 2 squared times 3. 2 squared times 3 there. I have 4 times 2 is 8. So I have 8 r's right here. And 1 right there. So that's 9. So that accounts for my 9 r's. And then here I have s. 2 times 6 is 12, so all of them are accounted for here. Now I want to go back and find all my indexes, all my exponents that match my index. So my index is a known 2. That means this 2 comes out front. This is the index of a 2. That means this r to the 4 comes out front. This index is a 2, so s to the 6 comes out front. Okay. Now, everything else stays underneath. So this 3 is left under, and this r is left under, and this is our answer. So basically, we really focus on matching our index. Like our target is our index, and we want to try to rewrite our radicand so that we can simplify it according to our index. Okay, now we're going to have quotient rules. So basically, we're going to break this apart into square root of 8 over square root of 81. Square root of 81 is simple. It's just 9. Well, 8 is going to be 2 times 4, and 4 is 2 times 2. So we have 2 squared times 2 because we want to match our index. So this, we get a 2 square root of 2 up top, and just, we already did the square root of 81 is 9 on the bottom, and then that doesn't simplify any further. Next we have the square root of 5 over the square root of 121. The square root of 5 doesn't simplify, and the square root of 121 is 11, so we just leave it there. And our last one, we're going to do the fourth root, so that's y with an index of 4. We're going to rewrite this one as 81x to the 4th with an index of 4. So if we break 81 down, that's 9 times 9, and then that's 3 times 3, which is, and then this one is 3 times 3. So I can rewrite that as 3 to the 4th power. So in the bottom we can map our index. So that's 3 to the 4th power, x to the 4th, okay. So now the top is left alone. We just leave it alone, so there's nothing else you can do to that. But in the bottom we have this comes out, a 3, and an x comes out. So we have, this is going to be our solution. So basically just remember that our index is our main focus, and we're trying to simplify that according to our index.